And now we put it all together. If you missed the last 4 episodes, check them out, link below. But for those of you who haven't, let's check out how to get started with Kubernetes. With a whole universe of things to learn, it's important to start with the essentials. Let's go over the concepts that make Kubernetes usable, scalable, and just downright awesome. Are you ready? Hey, Kaslin, thanks for joining me in this culminating video. Before we talked about containers and some other things, but it was mostly theoretical. It would be great to see an example in action. What do you think?
Yeah, sounds good to me. You remember in the last episodes how we talked about containers and deploying those containers onto Kubernetes?
Yeah, I went back, I rewatched all the old episodes. We talked about nodes, we talked about containers, and we even talked about the basic Kubernetes API objects. But one thing was we deployed everything imperatively, which you said wasn't going to scale well, right?
Right. So this time I'm going to show you how to deploy an app declaratively.
Great. I can't wait to see how it works.
Now we're going to explore how to deploy applications and containers declaratively using Kubernetes. If you remember in the last video, we talked about deployments in Kubernetes and how to create them. But the command that we used in our last video to create a deployment was imperative. We told Kubernetes exactly what we wanted it to do, and it did it. In the real world, we don't really want to do things that way. We want to do things declaratively, by having a file that describes or declares what we want things to be like, and then we have Kubernetes do the hard work of figuring out how to make that happen. Having our state defined declaratively in files allows us to do some cool things, like make changes to our deployments by just changing the file describing it. We can also track those changes through source control and make use of great tools for deploying applications at scale like continuous integration and continuous deployment tools. So to start with, let's create a deployment like we did in the last video, but this time we'll do it declaratively. So here you can see that I'm in Google Cloud Platform, and I'm using the Cloud Shell terminal to interact with a Kubernetes cluster that I have already created. And if I run ls here, you'll see that I'm in a directory that has some subdirectories and some files. So the files for my microservice application that I'm going to need to create that microservice application in Kubernetes are all in these directories. So the first one that I'm going to look at is deployments hello.yaml. So in this case, I have all of my files separated by the type of Kubernetes resource that they define. You could do this in all sorts of ways. You don't have to do it with this structure or anything. It's just the way that it is here. So let's take a look at this. If you remember the last video, we had to tell Kubernetes what it was that we wanted it to create, which is a deployment in this case. So we're doing that again here. We're giving that deployment a name. We're telling Kubernetes a number of replicas that we want of the pods that will be in this deployment. If you remember that we went over those as well. And so here we're defining the actual containers that we're going to be running, the container image, and a bit more information about that. And you'll also see down here we have a liveness probe and a readiness probe, which we didn't really go over last time, but they are tools that Kubernetes provides to help make sure that your application is up and ready to receive traffic. So there's a bit more that you can learn about deployments. As you can see, this is a fairly, it's not really that long, but there are a few components in it that are worth learning a bit more about. So if you want to look into deployments a bit more, I would recommend it. So this is what we mean by declaring our desired state. All of the information about what we want this deployment to look like is here in this file. And if we wanted to make a change, like changing the image that we're going to be running in this deployment, we could do that in this file and we could track that change through source control. So the next thing I'm going to do, actually I want to look at one more file before I create anything. So let me look at, within services, I have another file called hello.yaml. So if you remember from the last video, we created our deployment with our application, but then we needed some way to reach our application. And we did that by creating a Kubernetes service. So this is what this is going to do. This is creating another Kubernetes service that will allow us to connect to our Hello application, which will be deployed in its own deployment. So this service definition is pretty simple. It just has a name for the service. It has a selector which tells the service how to find the backends that it is serving. And then it has some port information that will allow us to actually reach that application. So if I want to create these, and I want to do it in a declarative way, what I'm going to do is run kubectl apply -f and give it the file name. So let's say deployments hello.yaml. And I can do more than one at a time. I can just add another -f here and specify my service and create my service at the same time. So that's pretty cool. The kubectl apply command doesn't know which API object you're creating, so you can specify it in the file and then just give it those files. So it's pretty versatile. So let's go ahead and create those. So you can see that my deployment and my service were created. But it wouldn't be a microservice application if it wasn't split up into multiple services. So the next service that I'm going to deploy, I'm going to deploy in exactly the same way. I'm going to do kubectl apply -f and then grab another deployment. And this time I'm going to deploy my frontend.yaml. So for this application, I've added in an Nginx server, which will act as my front end. And by the way, if you want to try this stuff out for yourself and follow along or just kind of play around with it, check out the links below. We'll have some information for you to get hands-on with this. So we're going to run kubectl apply and we'll give it the file for our front-end deployment. And once again, we're going to need a service for that. So let's create our frontend.yaml service as well. Now, an interesting thing here is I'm using the kubectl apply command because if that resource doesn't exist, the apply command will go ahead and create the resource. So I didn't have a front-end deployment or a front-end service before, so it went ahead and created those. But if I were to run this command again, you'll see that it says that the front-end and the deployment and its service were unchanged. So if we were to make a change to our deployment, like I said earlier, if we were to update the container image or something like that in our deployment file, where we have declared what we want our deployment to look like, then we would be able to just apply that change. And in the case of deployments, there are settings within Kubernetes that you can use to tell it how to roll out that change when you apply a new change. So in that way, this is a very declarative way to create resources in Kubernetes. But now that I have an Nginx component to my application, there are some configuration information that I want to pass into my Nginx server. And it didn't really make sense to add that stuff into the container definition, and it didn't really make sense to add that at any point along the way in creating the Kubernetes deployment. So how am I going to get that configuration information into my Nginx server now? Luckily, Kubernetes has a tool for that called ConfigMaps. A config map lets you map your configuration information to your application running in a Kubernetes deployment. I already have a file here which has the configuration information that I need for my Nginx frontend, and it's in nginxfrontend.conf. So you can see here that this is a bunch of configuration information for my Nginx frontend, but you'll see that it's not in YAML farm. So this is not actually declaratively declared. So I'm going to have to create this just using the configuration file as it is. So what I'm going to do is run kubectl create configmap is the type of Kubernetes object that I want to create, and I'm going to give that a name, which I'm just going to call it Nginx frontend conf, and I'm going to tell it I want it to create that config map from a file with information. File which is nginx/frontend.conf. Cool. So this will go ahead and create the config map from that configuration information that I showed you a minute ago. But I have another problem. I want to run this application a bit more securely, and I want to use TLS with it. But for that, I'm going to need to pass it some TLS certs, which I don't really want to pass in a config map because that information is just kind of plain text. I want to make sure that that information is kept more, well, secret. So Kubernetes has a great tool for this called secrets. Now, there are a lot of different tools for passing sensitive information in Kubernetes, so Kubernetes secrets might not be the best tool for your use case. You'll have to do a little bit of research to figure it out. But in my case, Kubernetes secrets are going to be just fine. They'll encrypt the information that I'm passing into my application, so let's go ahead and create a secret to pass my application the TLS certs that I have for it. So kubectl create is what I'm going to use again. Secrets are very similar to ConfigMaps, except they're for secret information. So create a secret, and there are a few different types of secrets, but for this one, I'm just going to create a generic one. And I'm going to give it a name, TLS certs, and I'm going to create that once again from a file. And that will be the TLS certs that I have in my directory. So that secret was created. And now there's one more piece of my microservice application, and that is an authentication tool that I've added into the microservice. So what that's going to look like is, once again, coming back to that trusty kubectl apply -f, and I'm going to grab a service for my auth.yaml component of my microservice. And of course, I'm going to need something for that service to serve, which will be a deployment once again. And that's going to be auth.yaml as well. And I appear to have mistyped something. Oh, I didn't put a -f before my deployments file. So you do have to put a -f for each file that you're passing it. So there you go. You can see that I've gone on ahead and created the service and the deployment for my authentication component of my microservice. And that's it. That's my whole microservice that I'm going to be showing you today. But how do I make sure that it's working properly? Well, the best way is always to test, right? So I'm going to run kubectl get services, or just SVC for short. And I want to get the information for my front end. So you'll see that my front end service is of type load balancer. In this case, that means that it created an actual load balancer resource in Google Cloud. And that external kind of load balancer resource has created an external IP for us that we will actually be able to use to reach the application that I've created. So I'm going to copy that IP. And I'm going to export it as a variable just to make my following commands a little bit easier. External IP. And give it that number. Okay, so I've created my variable. So now I can run a curl command to test to make sure that my application is running correctly. And if you'll remember earlier, we incorporated some security capabilities into this application. But let's say that I just curled that IP. What would happen? Actually, I'm just going to paste it in, even though I just did that. So if I curl that, nothing happens. Why is that? Of course, it's because we set up TLS and we set up some security measures. So now we're going to have to connect to this application using HTTPS a bit more securely. So I'm going to run curl-k https : and give it that IP. And there you go. So we've got our message output of hello. And that's all I expected this application to do. So I know that the application is up and running properly. But I also incorporated this authentication capability. And so I can also connect to this application as a specific user and make use of it that way. So for that, I'm going to have to get a token to log in as a specific user. So what that's going to look like, already did it, so I'm gonna go ahead and enter the password for the user. So what you can see here is I set up a token, which equals a curl command logging in as a specific user. I'm grabbing the token from that login. I had to enter the password for that user, and so now I have this token that I can use to access the website as well. So now I'm going to go ahead and run a curl command where I am passing in that token. So I'm logging in as a specific user. And if I run that, I get the same result. So I know that I can reach my application by using this authorization capability that I added in. So cool stuff. I went through and I created deployments and config maps and secrets, and for the deployments and the services, I did it in a declarative way, using these files that I can then go in and make changes to, track those changes, and do a lot of really cool stuff with automation and running applications at scale. So this is going to be really useful.
Great. So that's how I can run my application declaratively.
Right. Running things declaratively is really useful in the real world. Running your deployments based on a file makes it easy to set up CI/CD, source control, and other processes that are useful for running applications at scale.
Wow. Thanks to Kaslin for taking the time to show me how this all works. This wraps up the most basic Kubernetes objects. Next time, we'll start looking into more advanced use cases and features of Kubernetes. Stay tuned. Oh, and be sure to follow along in the code lab link below to walk through this code if you want to get hands-on. And if you enjoyed this episode, subscribe for more.